So this is the 2015 Leaving Cert Higher Level Paper 2, and we're looking at question number 4. Two circles S and C touch internally at B, as shown. So here's the circle C and the circle S, and they touch at B. Part A says the equation of the circle S is x minus 1 all squared plus y plus 6 all squared is equal to 360. Write down the coordinates of the center of S, and then write down the radius of S in the form a root 10, where a is a natural number. So we want the center and radius of a circle. It's given to us in this form. In our tables book, I've taken this here from the tables book. If a circle is given, the equation of a circle is given in this format here, x minus h squared plus y minus k squared equals r squared, well then the h and the k will be the center. So in our case, and this is providing there's a negative sign in each bracket. So in the first one there is a negative sign, so the center is going to be center hk, so the center is 1 for h, and the k value will be negative 6, because there's a positive here and it should be a negative. That's the center of the circle. Write down the radius of S in the form a root 10. The radius will be on the right hand side, r squared. So we have 360 there. So r squared is 360. That means the radius will be the square root of 360. And if we put this in our calculator, you will get a value of 6 root 10 when you simplify it. Just put this in your calculator, press equals. So 6 root 10 is in the form a root 10, where a is a complex number. So part B. B1 says the point K is the center of circle C. So here's the circle C and the point K, the center. The radius of C is 1/3 the radius of S. So the radius of C, so in other words the distance B to K, is 1/3 the distance B to the center here. The coordinates of B are 7, 12. So that's 7, 12. Find the coordinates of K. So we're looking for K. We know the center of this is 1 minus 6. And we're looking for K. Now we know that K is, if this is 1/3 of this total, well then we know that on this straight line that joins the 3 points, that 2/3 of the distance is center to K, and 1/3 is K to B. So 2/3 and then 1/3. So if we think of this in terms of a translation, if we're going from this center point here up to B, we're going from 1 to 7. 1 to 7 is a jump of 6. And if we look at the y, minus 6 up to 12, minus 6 up to 12, that's a jump of 18. Now, we don't go that full jump though to get to K, we go 2/3 of that. So if we do 2/3 of each of these values, we'll find the coordinate of K. So 2/3 of 6 is 4, and 2/3 of 18 is 12. So this is the amount we have to jump from the center. So if we go a jump of positive 4 from 1, in other words the 1 plus the 4 gives us 5, and from negative 6 we do a jump of 12, that gives us the y coordinate of 6. So then the point K is the point 5, 6. Okay, part 2 says find the equation of C. So C is the small circle, and we've to find the equation of C. Okay, so again, we can use the formula from the previous page, this formula here, x minus h squared plus y minus k squared equals r squared. So x minus h squared plus y minus k squared is equal to r squared, where h and k is the center and r is the radius. So the equation of C, the center of C was 5, 6, so it's x minus 5 squared plus y minus 6 squared is equal to the radius squared. And our radius, now the radius of C, if you remember, the radius of a small circle is 1/3 the radius of the big circle. So 1/3 of 6 root 10 would be that divided by 3, which is 2 root 10. So it's going to be 2 root 10 is the radius, but then that's squared in the formula. So that finally then gives us x minus 5 squared plus y minus 6 squared. You don't need to multiply these out. You can just leave them. Is equal to 2 root 10 squared. You can do this in your calculator, or 2 squared is 4, root 10 squared is 10, 4 tens is 40. So there's the equation of C. And finally, part C says find the equation of the common tangent at B. Give your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. Okay, so the common tangent at B, we just go back here. Common tangent is the line. I can draw it better than that. We do a bit of So if you can imagine, common tangent would be the line there that goes perpendicular to the line KB, or indeed the center here to be. It would be perpendicular to that, and it would be look like this. That would be the common tangent to both circles externally. So if we're looking for the common tangent, it's going to be a line, so we're going to use the formula for the equation of a line. So we're going to use this formula here, and to use this formula we need the slope m and a point x1, y1. So first of all, we're going to find the slope m. So the slope m, we can use this other formula, which I've also taken from the tables book here. So the slope would be well, I don't have 2 points on the, thinking about it here, I don't have 2 points on the common tangent B, but what I do have is 2 points along this line here. So I can use 2 points along the line here. I can just use K and the center, so that's 1, minus 6, and 5, 6. And I can find that slope, and then using that slope I can find the slope of a line perpendicular to it. So the slope of that line would be, let's see, let's just go back. We can use 1 and minus 6. So you've got 1 minus 6, and then K, which was 5, 6. You could use B as well, but use K, 5, 6. Okay, so that's going to be our x1, y1, x2, y2. Doesn't matter which point you call x1, y1, which one you call x2, y2. Substituting them into this slope formula here, we get the slope is equal to y2 minus y1, so that's 6 minus 6, all over x2 minus x1, which is 5 minus 1, and that gives us a value of 12 over 4, which is 3. Now, that's the slope of this line here, so the slope of the common tangent would be perpendicular to that. So a perpendicular line, if you want to find the slope of a perpendicular line, you can just flip this upside down. If this was a fraction, 3 would be 3 over 1, so the slope we want is this fraction flipped upside down with the sign changed. In other words, minus 1/3. So that's the slope that we're going to use in this formula here, the common tangent. And then all we need is another point, so we can just use any point on the common tangent. Now the only point we know on the common tangent is 7, 12, so we're going to use that point. So what we have then is y minus y1, 7, 12, in this case will be our x1 and our y1. So it's y minus 12 is equal to the slope m, which is minus 1/3 from here, multiplied by x minus the x1, which is 7. So now we just need to tidy this up into the form ax plus by plus c equals 0. So let's do that. Actually, the easiest way to do this would be to multiply everything by 3 to get rid of the minus 1/3. That would give us 3y minus 36 is equal to minus 1 by the x minus 7. Leave the left for now, sort out the right. Minus 1 by x is minus 1x, and minus 1 by minus 7 is positive 7. So finally then we're going to bring both of these over to the left. That becomes 1x, and then positive 7 becomes a negative 7. So that gives me 1x plus 3y minus 36 minus 7 is minus 43, and equal to 0 on the right side. And there we have a, b, c, all integers. A is 1, b is 3, and c is minus 43, but they're all integers, positive or negative whole numbers. So that is the end of part C and the end of question 4.